Without taking much time, I would like to welcome Amit for the SEMCON 2021 online conference. And let me take this opportunity to introduce Amit once again. Amit is head for Precast initiative at Larsen and Toubro Limited. He joined India's leading construction company, L&T Limited, as a part of Precast initiative for the residential building in 2012, and he had over a decade of precast construction experience in the United States with a leading precast concrete manufacturer. He's currently heading the precast initiative for buildings and factories and is actively involved in developing and promoting precast technology adoption in residential and commercial building sector. So Amit, we welcome you on behalf of ICA Pune Center and Team SEMCON 2021. Request you to start with your presentation, please.
Good evening, everyone. Thanks to Pune Center and SEMCON organizers as well. This is a great platform us to discuss about precast. So that topic, we had this seminar in November, and now we are doing the online version as well. Presentation today, I am just going to talk about state of the art of precast technology in L&T. Right, we call it state of the art because usually whatever is we are pursuing at L&T is treated as one of the latest and greatest. So the presentation, when the topic discussion came saying you wanted to do the recent advances in precast, we said we will just put it what we are doing, especially in the building sector. So of course L&T doesn't need introduction, but we take pride in being a professionally managed company and one of the leading innovative companies when it comes to construction industry space. Now I come from the buildings and factories group, so that's why again the topic today will be focusing more on what we are doing in this buildings space using precast technology, why we are doing it. Not a lot of people actually at times are aware we have a great presence in residential building sector, but the focus of the group has been of course the tallest buildings. What you see in the picture is one of the our actual projects in Mumbai, but we do a lot of work in the residential sector itself, especially mass housing. So we know the end user expectations really well. We know how the construction challenges of going vertical are and what needs to be dealt with. Right. Obviously, in the buildings area, we have presence in public spaces also, some of the landmark projects. But especially if you focus in precast, then one of the recent in other than buildings is of course the Narendra Modi Motera Stadium, and now we are doing the high-speed railway project. So whatever that we are discussing, whatever the precast technology adoption at L&T is not just from one source. It's these multiple areas, multiple expertise, multiple experts that feedback how we build the technologies to be sector. The overall flow of today's presentation, I think time compared to last time. So I would still try to wrap it up in maybe about 45 minutes. Same theme, maybe I'll spend a little more time in a couple of areas. But by about 6:45, 6:50, we will finish, and then 10 minutes of Q&A. The overall flow, I think the industry shift that we are seeing now, especially post-COVID, we are seeing it even more dramatically, saying I want to do precast. Why is because of course the workforce challenges are there, the skilled workforce issues are there. Whatever was there earlier, even from 2014-15 timeframe that we are seeing, it seems to have been even aggravated during COVID or post-COVID. So that then overall design philosophy, why we are doing it, how we are doing it, and then I'll be more basing it on case studies. So that case study basically our residential projects, what we are looking at, and then I'll kind of interview between the case studies and the points that we would like to discuss. Uh, Through that, we will go through the production process, the QA/QC, what we are doing against, especially joints or making them watertight and all those. With that, we will fall into our actually ongoing recent projects. So how we have adopted now over the last 8-9 years of overall technology development, how it is actually going into a real-time project. And then I will conclude on the, of course, digital ways in precast, right? If I think many of you probably already aware, but L&T Construction, the management from 2016 onwards have taken keen interest on making digitalization in construction industry. So in all facets of construction, we try to adopt that and see how it can basically improve my top line as well as the bottom line. So what we are doing in precast, that we will discuss. Right. This one slide, if you see now, it pretty much gives the history of how construction has evolved at L&T. If you see on the very topmost right, the conventional construction, we have been doing that for a long now. And in the 90s, right, everything has been for that rapid or built faster. We tried tunnel form, went into aluminum formwork system in about 2002, and that became probably one of the most popular options. Even now, 95% of our key large projects in residential, we still use the aluminum formwork. And in then 2010 time frame, the time came where the management felt that whatever we are doing in aluminum formwork, it is all working well, very popular, but we still need something faster. The kind of projects that we are looking at, this speed is not enough. And then came the 2014 timeframe, which is the Housing for All initiative, and this is exactly why and what we are actually building the precast technology for, like very large scale mass housing in a done in a very short time. So if you see the screen now, I think just to give you a comparison, the CIP is the cast in place in aluminum formwork system. And we just wanted to compare how the precast works, right? In one project where we have these both systems, similar project, same environment, same challenges during COVID time frame. And we wanted to see how we are doing, just comparing ourselves. So this is 25 slabs using precast or cast in place, right? How many number of days and everything. And the table doesn't mean anything, but once you start looking at filtering the data and maybe start comparing apples to apples, this is what you are going to see. What I would like to drive is the cycle time is the normal means, right? This is the metric now the current industry sees, is how fast you are building, how much is the time taken for your per floor. What is also important at the same time is how much of your resources are used for that cycle time, right? Otherwise, we have, if we have infinite resources, we can build even much faster than what you're looking here. So that's my comparison, apple to apple comparison is cycle time, number of days per floor in what resources. And if you see conventional, usually the key resource is going to be your aluminum formwork set. Right? We have sometimes 20 sets, 8 sets, whatever they are. In precast, that same resource becomes my tower crane. Right? So so what we are looking here is the number of days for those. What was my cycle time per resource? So for my precast, it was 25 days. For cast in place, it was about 38 days. So this is the whatever 20-30% reduction that you see in terms of the cycle time. What I would like to drive now as the project has progressed. Of course, if you see that conventional, usually then that initial curve and all, it dips, it drops, and it kind of settles. And here, based on the actual COVID challenges, sometimes it has gone up also. But if you see precast, it has dropped drastically and then it has maintained, right? This is where that workforce challenges that you see at site level, they become not that important, because once you start getting through your factory productivity and all, everything is, the site challenges are less, or the site impact is less. And this is why one of the key reason why we are doing work or why we are pursuing precast technologies. I don't want that risk of site challenges. Right? If you see now this another productivity metrics, if you see aluminum formwork, I'm looking at about 5.5 man days spent per cubic meter. And of course, these numbers, if you see 3.5, 2.5, they are better. Of course, because you are putting the technology at work, because you're putting a huge factory expense. But what we would want to see is all these 5.5 is spent at site, whereas in these other options, only a portion of it is at centered site, and everything usually other thing is being done at the factory. So again, my risk at site is what we want to reduce. The overall reduction in the site activities, that is the goal than the blanket uh, floor cycle time metrics. And how we do it, if you see, this is the typical activities that you will see what we do at conventional construction methods. You have the formwork, reinforcement, concreting, then you do the block work, plastering, pop. This is a pretty conventional cycle. And what we have done in both aluminum formwork and precast is that workforce intensive activities, we are trying to eliminate those. So in our construction now, 2002 is what I showed you, the aluminum formwork system. Since then we have avoided these activities, we don't do this anymore. And then precast, whatever the still cumbersome activities left, we are still doing those at factory and then trying to get by. So with that background, why precast is this picture, right? This is the volume that when we say 2014 housing for all came, this is where we were looking at mass housing as is multiple buildings, generally of the same types, not very many flat types, and just huge volumes. This is from AP actually. That project included 1 lakh houses in about a span of 3 to 4 years. So this is the kind of projects that we are trying to see, look at, and then do precast technology or any mechanization. I'm not saying particularly precast per se, but mechanization, automation is where the speed will come in. Now this mass housing challenge, if you see, it's nothing new, right? We have seen this outside. If you see our neighbors, Singapore, Shanghai, Tokyo, Hong Kong, everybody has done this. They have gone through that system. They have built excellent public housing systems. What we are looking at is the time frame. All these guys have done that in the time frame of 20 to 25 years, whereas we are looking at a time frame of about 7 years when it was announced, but let's 7 to 10 years. The other aspect is, especially in residential, is if you see, example Mumbai, we are actually doing the latest and greatest already in the infrastructure sector, right? We are doing all this precasting they are doing for long. If you see now Mumbai, we have high speed railway going on one side, we have the coastal road going on, we have the Trans Harbour Link project going on, there is metro construction going on. And if you look at all these projects, precasting has become the core of these projects, right? That's where we are doing, and that has worked well. In residential, however, somehow that has not picked up. We are still doing a lot of the mass of the market is still doing older construction ways. But if you see our neighbors, that's how these guys address that challenge, right? Again, not by precast technology. They have addressed it saying you mechanize it, you automate it. So that's what the new challenge, new technologies should concern or be looked at too. The other thing using automation and mechanization is your activities at site, like I was saying. If you see this picture, the system, where you will see once the floor cycle is done, only about 50% of the work is done. What we are doing on the versus side, which is precast or aluminum, what I'm seeing is, but when I say my floor cycle is done in 8 days, 90% of the work is done. Right now, we are looking at in this building externally only painting and then internal finishing. So that is what is driving us. From the end user perspective, now if you see all these systems, we are avoiding plaster. I think the one point if you, I would like to deliver is from your end user perspective, all these modern technologies, we are eliminating internal and external plaster, right? Of course, for us, it's a faster work, but if you see from the end user perspective, the plaster is never meant for being a lifelong element, right? It's a sand cement mortar. It doesn't have inherent strength. You start seeing issues 5, 6 years or 10 years down the line with these cracks, maintenance, the paint fades. So that all issues are not going to be there in what we have selected as our construction systems. So with that background, now getting into actual case studies, the picture that you see is actually one of our first projects where we use precast technology for residential buildings. This is in Mumbai, near Dadar. In picture, you see 3 buildings, ground plus 23-story tall buildings, and these were built using precast elements right from the ground floor all the way to terrace. Whatever you see in these buildings, including the external panels, the shafts, the stairs, elevator shafts, everything was built using precast technology. We built three more buildings here, so about 2,000 flats were built. The building won, of course, several awards also. This was started in 2011 time frame and then handed over in about 2014 time frame. The second case study where I'll spend a little more time in terms of pictures and detailing is our next project. When we got the learnings of this Mumbai project, then we got into the next phase where we took up this project for a private client. It's in Bangalore, and it is a regular sale type project, about 66 towers, around 6.6 million square feet of built up area. We have completed about 3 million square feet of it, about 35 towers, ground plus 14 story tall. And again, this is all in total precast system. Before we get into the projects, this certificate is kind of very close to our heart, has come extemporary from the developer, saying that one tower, once we start getting into the groove at the peak, we finish that 112-story tower in 3 months flat. Like when from the ground to all the way to terrace, this was constructed in 3 months. That's where the speed of the technology is what come into picture. Now all towers were not 3 months, but from that peak, then on an average we were doing 3 to 4 months, 3 to 4 months per tower. So that's where that speed will come into picture. This is some same pictures of that finished buildings, the two phases that what I was saying. Now in this picture, actually what we would like to drive is, again, once finished, these buildings are going to look very similar to what your end user is expecting, right? Because it is done in some different technology for a contractor's perspective. We don't want to force something onto the end user. Larsen to details, a lot of design philosophy goes into this development stage where we look at these final get these things working out. But like you said, the finished building, the elevational treatments, the balconies, the chajjas, the sunset, whatever that you see, that has been designed and dealt with according to the end users in mind. On a different perspective, now this is actually a project in VNRI Urbana, which is in Kolkata. This was only the facade, but if you see this area, the architect kind of envisioned this wave pattern on the facade. Right? If you see everywhere, this is done that way. Now, if you do or intend to do this in conventional, making your formwork changes and all, it will be a nightmare, right? So we took that quick call, saying instead of that, you finish those in precast. So those elements were cast offsite nearby, and then were attached to the building for that pattern, and then it kind of worked really well. This is another example in total precast system, again a commercial building. This is for Cognizant Technologies. We did their canteen building in total precast. If you see, this is column precast, beams precast, and then we use the system. So the choice for the system, what works, what doesn't work, we have an in-house engineering department that takes these calls, right? We don't want to force. So on the same line, this is another project in Mumbai. This is our domestic domestic airport terminal, MLCP. If you go to domestic terminal, on your left hand side at the entrance, you are going to see this parking structure. This was done again total precast system, but if finished outside, where you cannot even make out what kind of system it was used. But here also we had now beams and columns and hollow core slabs. Same way, another building in Bangalore for Wipro. So here in these bands were envisioned in concrete, and they were kind of the bands are inside. So it is very tricky to do formwork or shift formwork. So we did those in precast. So all these bands were attached to the structure later in precast, and that worked out well. This is another example, different. I just wanted to give a flavor what we are doing in the residential and commercial space. This is one of the recent projects in our Ikea warehouse in Mumbai. So here it's a hybrid structure. So the steel columns and then hollow core slabs to make out your floor. What is unique is each slab is about 16-meter long, and it has a warehouse industrial load of about 750 kg per square meter. So this is one of the longest and deepest hollow core slabs in the country. This is 400 thick slab that was cast. And why it worked really well is one, industrial load, and that's where the pre-stressed or pre-tension systems come into picture. But second was the span, where there was no false work done on the lower floor. Right, we just kept the hollow core slabs directly and then finished the floor. So this is your, actually, if you ever visit that IKEA store in Mumbai, this is your top floor. So if you're walking on a floor where all these furniture and rooms are set up, you're walking on the hollow core slabs. So with this background now, where will we go? Right, this is the crux of the presentation today. So if we want to put it in a short summary, this is where we see the entire industry now going. If you see, there is no particular technology over the years that we feel will govern or dedicate, but the hybrid technology and the prefab or pre-finished concept, that is probably here to stay. No matter what you do or which technology you will do, everybody will be focusing on that. Again, less work at site and do combination so that you get the net benefit of the overall system and don't get stuck to a particular system. In general, market wise, if you want to look at this S curve, this is your low rise market, which is G+1, G+4 houses, where we are already exploring now 3D printing. We have approvals and we will be getting into that space. Maybe by April, May, we'll have our own setup printing, actually printing these buildings. So we are doing comfortable in aluminum formwork in that space, but 3D printing is going to be the newer one, system wise. Same way, if you go mid-rise, we are doing precast now, but we will be shifting towards PPVC, which is the volumetric construction, where you will finish everything at factory and erect it. And if you see the high-rise sector, we are doing the jump from the climbing formwork, which will kind of will stay. But the facade, which is the usual challenging system, we may go to precast facade or prefabricated facade systems to cover these buildings. So in those lines, we have to think and then see how we go about it. Excuse me. Getting into the design, how we do design, basically, like I said, we have to look at it as a holistic approach. And usually L&T has that strength where we have our own in-house design department, not just the structural, but including the MEP architectural. We have the construction method services team. So that one single point of contact will give you the entire solution from the land development to the actual construction and handing over of the buildings. In that, then from the design perspective, we looking at two systems in precast. One is this large panel system, what you see in the picture, what we usually use for residential construction, or the framed system, which is what I showed the commercial projects. So usually precast beams, columns, and then your hollow core slabs or double T's, the long spanning system. Once you decide that system, then your work is fairly straightforward, right? It's not rocket science. You are going to split your elements. Floor plan, we don't have much luxury. Residential especially has its own taste. If you see outside projects, they are very simple projects, right? Buildings are usually boxy. They are modular, they are in grid. We don't have that luxury, so we kind of worked with it, saying that is never going to come. Our buildings will be complicated. We are looking at complicated elements. Just break them into two-dimensional elements as much as possible, produce them at factory, and then erect it. Right. So with that basic framework, now if you start looking at it, a lot of times the designers or as a client also, you will have a questionnaire saying how much precast should I do, what I do precast, whether I get the benefit or not. And if you look at those questions, usually I think we engineers will try to split it and make it simplify. So we thought we'll make it in terms of a 2 by 2 matrix. Right? So what are the benefits that I get? What are the efforts that I put? If I want high efforts and low benefits, I would say that's something as a premium, right? You like, this is something like I have to do precast, I will do precast. or if you have a high cost efficient system with lowest efforts, that is what you want, that is the bread and butter type, and it will make sense. If you're something here low and low, maybe you're doing precast, it doesn't matter. If you're something high efforts and high benefits, you will have to do something like that. So in general, if I start splitting the construction systems, then this is what you are going to see in your day-to-day buildings, whether commercial or residential. If you have external complicated 3D elements, these are high effort elements, but you get high benefits, right? You get easy 3D facade attached to the building, and you save a lot of time. Same things with the pods or stairs or external walls. They will come into where it's really worth looking at these elements and seeing if you can convert it to precast. If you look at architectural treatments and projections, if you see it looks fancy, but you will be ending up with actually very high effort, but not as many benefits. So in our Provident job, if you see the architectural treatment, we did that with architecture alternate material. We did not force our technology. Same with water tanks. There is a lot of high effort. So you have to have really premium, really drive to do water tanks in precast, which in our now Sidco projects, we are doing that, but for different reasons. But believe me, to build that water tank, there is a lot of extra work to make it work. Columns, beams, very simple, but no benefit. Internal walls and slabs. Slabs, actually, if you see, this is where your highest benefit element will come from precast, is where you don't have to spend as much, you don't have to put as many efforts. Simple slabs, but you get the benefit of no form work. Quickly put the slabs, exactly what I showed in that IKEA warehouse, right? There is no form work, false work, long span areas, literally 50 to 60% improvement in the overall productivity. So on those lines, then you can have your own 2 by 2, see what your benefits are, what is that is driving you as a client or as a contractor or as an end user, and then decide what kind of precast you want to do. Once you take that call, whether entire building and all, then you get into your structural system. What we are doing is emulative detailing, right? This is one slide, I think, summary if you're in the structural design department. This is what we are using in India now, whether it's a beam column system or it's a large panel system for residential or commercial buildings. We are using the emulative approach. Outside world for last 20 years has been doing the bolted and welded connection approach. Right? Before I came back to India, I didn't know what emulative detailing is. Right? I've always seen welded and bolted connections when I started work. But maybe we'll get there one day. But right now, where we stand, the system is working well for us in terms of this wet connection detailings. But what that emulative approach in bottom line says is, your building once completed, it's immaterial whether it was done in precast or conventional. It is going to behave similar to a conventional or a monolithically cast building. That's what the kind of connections we are using, the kind of detailings we are doing. A lot of extra efforts. Wet concreting takes a lot more time than welded or bolted connections. So that extra efforts is to get the performance similar, something what we are used to. And it's a globally accepted methodology. If you see ACI, they will say that the buildings will perform equivalent to your structural system. PCI, if you say, they take even further steps saying, regardless of any seismic region, if you are doing emulative detailing, your building is going to perform very similar. And just to have that validation, we did our in-house test also. I'm not going to get into details, we don't have time, but that test setup, entire thing is done in India, and where we validated, we showed this is a full 3 meter height shear wall system, which is pushed for the reverse cyclic loads to make sure that the emulative detailing, one element was cast in place, the others were 3 different joints, and we tried to see whether that emulative or similar performance is achieved or not. And if you see this graph, this is where one of the wall is your conventional wall, and these are the precast walls. So we do get that similar performance. The R values, what we are looking at, our overall strength and the toughness is similar. The especially make connections what we use for couplers and all, also that's what also was tested, and the couplers usually will give you slightly better performance. But of course, they are having their own detailing issues, or it takes a little more time to build the elements at site too. So that cost benefit you have to do on your own and see. But the ductility mainly, where usually precast gets questions saying whether you get the same performance or not. This is the actually proof of pudding. If you see these coupler connections, this is been tested at maybe a seismic event of more than zone 4, and the bar has yielded, gave the ductility that you want. The connection never failed, and that's how you are getting that better performance out of it. On similar lines, we have done all other elements also. The entire, usually the building structure, building system, or the building load path has been tested and validated for the details that we are using to show that we get the satisfactory performance in terms of shear wall connections, in terms of your diaphragm behavior, in terms of connections that give you the shear capacity. And based on that, then we have these several technology validations and certifications in place, just so that you have that comfort that in 2012, when we were saying, okay, new technology, we have to do something. From that to now, we have the industry overall has seen a lot in precast, and that comfort, that confidence that we have is plenty there, where we don't have any issues left to deal with, especially in terms of structural or joint connections. Now getting into more of actually operating and how to build these buildings. If you start looking at these pictures again, these are actually during construction, same Provident project, and we are getting into how we produce or how we manufacture. If you see the factory here, this is Bangalore, so it rarely rains. So we ended up with like an open factory, right? The cost is always there, right? That parameter you have to always justify, no matter what technology you're using, no matter how fast you're building. If it's going to cost you a little more than the conventional, you're not there. That is the industry, Indian industry, that we're seeing. So in that mind, we set up the factories, we see what speed to build and how to build it. So this build project, if you see, it was an open factory, right? We don't have to spend money for covering it up, because it only rarely rains. If you see our Mumbai project, it rains. I think last year it rained in 8 months. So we usually have the closed shed, and then make sure that the factory is running well. This one picture, if you see that, I think wherever I speak, I usually highlight this is where the benefit of the technology is, right? This picture is not taken on a Sunday; it's on a full working day. But if it's an aluminum formwork or a conventional system, you're going to see an army of people walking around, safety screens, material stacked. It's just busy. And here you will see this 3 4 usually a 10 15 people gang is what is on the floor. They will do their work. There are no safety screens because the panel itself lacks that safety, and then they will just do about maybe 30 35 panels per day, and that will give you that speed of what we are looking at 4-day cycle or 5-day cycle. But then again, the driving factor is lesser the probability of incident, better control on site. The site are more safer and secure, and that's why we are driving this technologies for. Your overall quality control is going to be much better in terms of everything happens at ground, right? There is something happening on the 23rd floor versus something happening on the ground in factory controlled environment is much better. As far as the conduits or your services are concerned, everything is concealed, so that same benefit you get out of it. Conduits are usually cast embedded in your PHE plumbing. Usually we provide chases so that you get the access, so that if at all it leaks and all, you can access it and maintain it. Your transportation and all is figured out. That becomes actually one challenge. Usually we avoid it by setting up the factories at the site itself. So that infrastructure challenge, I don't have to deal with it personally, but it is there. Maybe I think another 5 6 years we might be seeing where we have better infrastructure to deal with the technology better. Once it goes to the sub, like I said again, the 10 15 gang, they are there, they know what to do, and very minimal work, just line level, make sure your elements are plumb, and just continue erecting. It is a fairly straightforward process, as long as is dealt well during design stage on paper. Right, so this is that architects vision was in 2014 when he conceived the job. This is how it was delivered in about 2.5 years later. Right? So this is our one flagship project. I think I have about 15 more minutes. So going to another one quick. This is a very small project, but I just wanted to give you the flavor for the audience, saying how you can adopt technology. Right? It's usually even our focus is on mega projects, but every now and then you get this like small scale, but which kind of fits in precast. So this was one hostel building that we looked at in precast, and the building, if you see, it was G+3 because the client wanted it in 8 months, and they said if I build all 5 floors I will be late, so just give me 3 floors and then 2 extra floors. By the time we started construction, looking at the speed, they said might as well build the 2 floors and you may not be late. So we built that all 5 levels and got that structure in time. But why it's unique? To improve that speed, usually we start on the ground floor. But here, because the founding strata was low, even the plinth was taken up using precast. So if you see, this is my raft. At the start, top of the raft, we directly took up precast. This plinth work, usually what will take about 25 to 30 days, was erected in 3 days, and then backfill and all in about 7 to 8 days, and the work was done. So this is where you get the speed of the technology. Then inside building again, finished well and all, you don't see it. The bottom level was a big dining hall, so where that continuity or the walls could not continue. So we did a hybrid system of beam column portal frames. This is precast beam, precast column, and then the building continued on top. So if you look at it, various possibilities are there which can be easily done using the precast system, and much faster. This is one commercial job in Vizag. Now we are doing a substation building. So this is total precast substation. This project is about 15,000 crore worth. The substation building is about 50 crore. But substation building is kind of heart of the entire project. Until that is commissioned, nothing else can be handed over. So it becomes important and critical element. So the client said that we want it faster, so I don't want the risk. So that's how it has been conceived. This is one of the first substations we are doing, but going forward, we will see more and more in that same space. This is another job where we said only the facade we will do in precast. Why? Because if you see, the facade is the architect had vision of this C-shaped columns, right? This was done in block work before, but doing all that entire facade block work, we said we will rather do precast. So along with the C-shaped columns, we changed the spandrels also to precast. So there is a core system inside, and then we are kind of cladding that entire system using the spandrel and this C-shaped columns to finish the building. This another one we are looking at now, facade, is the building in Powai actually. This entire facade wall was planned in block work. So that we have converted, we said we'll put precast panels. So these are 125 thick panels because it's just a cladding system, and finished using a sealant joint. But this is actually welded connection. So now this is that ultra rapid connection. So we are ending with that. I told you that cumulative is where what we are doing, but that's for my main structure. I want it faster, so then we selected here welding connection. But this one panel, which is about 2.3 meter wide and 4 meter tall, is attached to the structure in under 30 minutes. So that's why that welded connection impact is there, and then we are not doing any activities. Just the wall panels are painted and then finished. Same way here we are doing in residential is this pre-finished bath. So if you see this toilet about 10 ton including finishing, but all this finishing and everything is finished in the factory. So we set up the factory right at that next to the job. All indigenous molds done our own form of department, and then these pots they were stored at site and then finished at ground. So that way I saved on the overall finishing activity at site. And all those toilet pots were just kept constructed with the building. And at the time of handover, those were opened. Only the door was attached fresh, and then so with that, I think we are at the last end, maybe another 10 minutes. And what we'll be looking at is overall QAQC, what we are doing, and joints, right? We already discussed about the structural integrity quickly. and how we are doing it. In terms of joints and water issues, what I would like to stress is, as long as you know what you're doing, as long as you look closely and detail that joints out, it is very possible and very comfortably done to have long lasting buildings which will not have the water leakage issues. In terms of, in general, the water leakage issues, where I stand now, my experience along the last 10 years is, in India we don't have water leakage issues in precast anymore, right? I have a water seepage issue, I have a moisture issue. But what we were seeing in the first, when we started this technology, where 10% of the joints are leaking and there is dripping water, that has gone. What I'm looking at now is probably less than 1% of the joints issues. Even with that, I will say maybe a moisture or seepage issue, but there is no drastic water issues. The building that you see in the picture here is a total precast building done by Shirish Patel and Associates in 1972. Building has been standing there for now more than 45 years without any significant issues. So if you know what you're doing, if you pay attention to details, there is very possible or highly possible to build buildings which will be there standing for your 50 years of life. So how we do it, we have also evolved over the years. These are the some of the typical details, how we do the detailing, where you to avoid, make sure that water does not climb up. We do waterproofing with an intent where there should not be a leakage from one room to another. Forget one flat to another. So all these details and all will look at it and finish it. After finishing, these will be tested also. About 2% of the flats, we are actually literally ponding the flats about 4 hours of water and making sure that the vulnerable areas are found out. If there are areas where seepage, those get treated, but this is being looked at. So this one thing actually, I'll just one minute or so, but this I wanted to put it because that question keeps coming. So it's a small video of, this is our recent project in Mumbai, and a small video where we actually pond the flats. So we ponded this flat also for about 4 hours of water. And then there is a walkthrough of what you get to see under that flat, like the one level below. And this is what we are actually getting now. That's where the confidence, when I stand here and say that I don't have a water leakage issue, only moisture issue, is this. Entire flat usually is flooded. Like I said, about 4 hours. That's the new norm. And this is anything beyond that. We have come or perfected that technology where we can confidently deliver these kinds of units. All these joints you see, this is as good as looking at a water tank below, which had 1 inch of ponded water for 24 hours. That's this also, you see, it is very common in precast slabs to see some hairline cracks and all, because these are thin slabs, and usually everybody is concerned saying these cracks and it will leak and all. But once you put the topping on top of it, these cracks usually do not have any issues. So that's the entire flat going out, and sparkling. This is what we can deliver. One, attention to detail during design, and then make sure that your QAQC at site is working well, where you can achieve this kind of performance. All right, going back quickly. Same way internal, we are doing external testing also. So if you see now, the newest code 15916, which is the precast code, has now has given requirements for the external joint testing also. So same is followed, where we do kind of simulate the rainfall situation and test the joints to make sure that they are as expected. Right. At the last end, I'm just going to show, I think the video that you saw just now is from that Sidco project only. So this, we are building actually about 7,500 houses now. Based on all our experience, this we selected precast technology for this. Also, it was qualified by Sidco as their preferred choice of construction. And we are looking at about 4.5 million square feet of work. The speed overall, if you look at that, we are looking at about 30 floors per month. which will translate to about 8 flats per day. So that's what we are looking at in terms of volume. This is the overall perspective of one of the plots. So all these buildings, what you see, we are building using precast technology now. The architect is architect Hafiz contractor. So these are not your traditional mass housing type buildings. So they wanted, they were very particular about their brand. So if you see there all grooves and reveals and projections and all that was worked out, and entire thing is being produced in the precast system along with the architectural features. This is during construction. This snap, it was built right in COVID wave 2. In starting production and about 2.2 million square feet a year capacity. Uh, 90% of the molds are built indigenous, and this is that what I was showing the panel. If you see with the grooves, with the bands around windows, everything is cast at factory. Even first layer of paint and putty, we are trying to see if we can do it in factory and just install it at site. This is actually the site photograph. What you see here is pretty much built in last 7 months. So that's what we are looking at. This photo itself is about a month old photo. But that speed, what I was saying, about 30 floors a month, we are somewhere around 22 to 24 floors a month now. At the peak, we will get to about 30 floors a month using that plant speed. And to conclude, then in the digital space, what I was mentioning. So if you look at this project, whatever I mentioned, 4.5 million square feet, it broadly translates to about 1 lakh elements. And it's a huge amount to deal with in terms of your planning, logistics, and all. So what we have previously have Excel based planning and all will go out of toss if you want to kind of track these many elements. So right from the project start, we are now full-fledged using BIM for all most of our projects anyway. So there is a central BIM model for all these towers, and based on that BIM model, now we have our in-house app also that kind of tracks each element status-wise, right? So from the BIM model, I am already doing the modeling. If you see all the reinforcement of these panels, everything is modeled in that BIM model, right? All my 2D drawings are generated out of this BIM model now. There is no more 2D drafting going on. And once you have that in hand, then we switch to the site digital action is our app. Then right from the start of that project life or element life cycle, when the bed starts, we know that this element is being cast. Then at what time it was cast, how much time it took to get to the concrete stage, when it was demolding, what was the strength at the time of demold, how long it was in the storage, when it was transported, when it was erected at site. I have a real-time snapshot using that app. That's where the digital advantage we are looking at is. Usually what used to happen in traditional tracking is by the time the issue is flagged, it becomes 2 or 3 days delay already, because someone is going to input punch in that number next day morning, look at it, then they realize that's a problem, they will email it to, then people will start looking at it. Here, if 8 o'clock in the evening the element is installed, it gets scanned and gets reported saying that element is installed. If it was not, it gets flagged also. So I get that real-time snapshot throughout the project all the time out of whatever that 1 lakh elements, how we are doing on each element. Same way tower progress also. So we'll get to know using that app and all, saying how many towers are doing each floor, at what percentage it is, and everything is being tracked real time. So that's the digital advantage. And then lastly, to conclude, I think where will we go? I know I've been rushing a bunch of things, but of course, if you have questions, feel free to contact me. But with all this now, last 8, 9 years, where will we go? If you ask me, I just wanted to show some pictures that we have done in India and before coming back to India, I used to work with the precast sector. Projects where we'll probably now the industry will shift. Of course, residential will remain a different portfolio, but even in commercial, these projects, and why these projects, if you see, none of these projects, whatever I'm going to show now, there is external scaffolding used, right? These are finished architecturally treated panels in the factory and installed at site. The only external work was the joint sealant activity and then maybe basic cleaning. But what you see here, these are the brick panels. So these are the cast in bricks, all totally finished with the architectural treatments and everything, and just installed. This is where that industry will slowly move now next 5-10 years. We don't have people who can install the scaffolding and work and finish your buildings, right? In fact, in one of our internal meetings, our MD had asked saying, I don't want to paint the building. Right? You just do something at the factory and bring it. So that kind of level is being asked. And this is what it is. These buildings were not painted. The white element is the cement, white cement element. Same way, precast has to be modular. No, this is a total precast building. It doesn't have to be modular. But this is kind of that luxury I showed that 2x2 chart, right? It is expensive to build this building, but they build it using precast because there is a different manufacture or a different reasoning behind it. But if you want to do it, different elements, different balconies, different layouts, everything is done at factory. Building is not painted outside. Building, the bricks are not installed outside. These are all done in factory and then installed here. All architectural elements, all panels. This is a gray cement panel. This is a white cement panel. It's not painted. Pre-finished panels attached to the building. Same way here. It's a gray cement, white cement, long elements. It's a school building. So this is where I think the industry will go now. We are also exploring a lot of things where pre-finish, spend as less possible as time at site, spend as less time as possible maintaining your buildings. So with that, I think thank you for patient hearing. If you have any questions, we can take it up. If you want to connect after the session also, I'll be around. Thank you very much.
Yeah, thank you, Amit, for the excellent and exhaustive presentation. There are a lot many things I know you have covered. So, Amit, I have few questions. I'll just post few questions to you. So, you discuss about the joints, and also Mr. Ramesh, he would like you to discuss more on some various rigid joinery details, which can be used in, I guess he's saying, hydrocarbon industry.
Right. So rigid joints means, see, basically joints, when it comes to joints, it is either your pinned joint, which is simply supported, or your moment joint. I am guessing rigid joint means moment capacity, and that can be achieved easily also. So all these beam columns, one of the examples I showed you, the portal frame in that hostel building, that is actually a beam column moment frame. Right, we have not done that before. We usually, because there is a some amount of work goes into doing the beam column moment joint. But how it gives the benefit is, if you see, it's a hostel building and dining home. They had floor to floor height of 2 inches. So if I would have done a regular simply supported beam, that beam was coming almost about 1.1 meter. But instead, I did the moment connection there, and then the beam depth was controlled to about 700, where we could fit it in that same floor to floor. How we did that? There are coupler connections, or there are stitch. There are 10 different details available. You will have to look at it case by case joint. But building a precast beam column moment frame is not a task anymore. If your need is there, project need is there, you can design it, detail it, and quickly figure it out too.
And another question is how to make IS code acceptable for welded joints.
You just have to get together as a committee, debate it, look at the outside world, and make it a mainstream joy. Right? That's how the industry is shifting. Again, welded connections are not something that is to be shied away from. It's just that it needs higher quality control. Right? Usually, people are shy of welding is, but your steel industry is doing it for last 40 years. Everything revolves around welding. You just have to bring that in the construction, skilled welders available, and welded connections can do magic.
Okay, yeah. So we have another question from Mr. Pratap Kasbekar. So he's asking which aspects of precast building meets the lead criteria.
Okay. I actually I am a lead certified professional, but it's been a while since I practiced it. There are actually not great differences between, just because it's precast, because it will give you a lead criteria. it depends. You have to evaluate on your system, but items like use of local materials or use of recycled materials or controlling your wastage or controlling your impact on the environment. These are actually great areas where even in conventional system you cannot get those points easily. Right? For example, if I have to give you my old factory, not here, the US factory, they had a water recirculation plant in front of our eyes, and that gave the lead credit of recirculating the water. So things like that, if you put dedicated efforts, there are many areas where you can actually start claiming your lead points.
Okay. So we have one question from Mr. Jaydeep Patil. So he's asking, can we perform destructive testing on precast structural members? I guess he's asking maybe non-destructive testing.
Actually, I'll maybe answer both. Non-destructive anyway is a mainstream method here, but destructive means a full-scale test. What test I showed you, that 3 meter tall panel, it is actually a destructive test where we actually put that system under full reverse cyclic loads. So that is something not you can do day to day, but for our validation, for our own comfort, we did that entire program. It took us somewhere around 4 years to complete that entire program, and a lot of money. So it's not a easy way to do it. I don't think everybody has to do it. Whatever we needed is already there. But yeah, if you to actually that example I showed of the Richport building in 1972, they have done a full scale program that time also. If you get a chance, pretty fascinating stuff what he did in 1972 or 75 time frame. But they also put all these 4 meter tall panels and actually put to toast and tested the connections and all. So it is not something new that we have also done. But I don't think we need to do it anymore now. Even in India, we have that system in place. And like I said, it takes a lot of time and efforts to get that through your system. So.
Okay. So we have a question from Anurag sir also. So he says that IS codes in India does not support the precast technology. For example, like even you cannot take advantage of less cover for the reinforcement to reduce the weight and the cost. How do you think that it can be done? Or any your comments on that?
Yeah. So again, I think that's a great point. Actually, we have been also trying to put that a lot. I think for everybody's understanding, if you see ACI 318 precast is no different for the building code, which is equivalent to your 456. If you start reading through ACI 318 in code, you will say conventional, you do this. If you are precast, you do this. If you have lightweight concrete, you do this. Everything is covered under one body, and then there itself they will say, for this example, the cover question, the code will say that because precast build or factory manufactured concrete is under control environment, you can actually use reduced cover. So whatever, if the cast in place system has a 25 millimeter cover, they will say precast is okay with 20 millimeter cover. This is where you are actually that factory quality. Right now, we are just doing that cost without any benefits. I am still doing 25 millimeter cover and I'm producing the elements in factory. Now, to convert or to actually really tap the advantage of the system is where we have to get these things in the code. And there are some efforts already underway. So maybe over the times, of course, it takes time again. It may not be tomorrow, but there are efforts underway where there are specific committees now. BIS code is actually last, if you see 4 5 years, is extremely helpful and putting dedicated efforts and time to review the codes. If you see 1596, which is the precast one mainstream code is, that is there is a 20 lead code has been established just to focus on precast ports, which will actually hopefully in next 3 4 years time we'll start seeing more and more ports which are geared up for that industry, and then we take it from there.
Okay. Okay. So, also Sanjeev Kumar is asking which software is used for precast structure and its detailing. Any particular softwares you are using, as you said that it is your internal team only for structural designing and detailing.
Yeah, I think where we start, like I said, we are still using that emulative detailing. So my design philosophy, design approach is as good as the conventional building. We still use the ETAPS models only, and we do the same way design and all. Over the time, if we switch to bolted, jointed construction, then there are custom softwares available. Outside industry uses that, but currently it's a very conventional approach for us. So it's your standard day-to-day. The building design, as far as it's concerned, it is designed exactly same as conventional methods with the conventional tools. The only difference is if it's a conventional building, you will look at 3 floors, do the design, then another 7 floors. In precast, we are looking at joint by joint, level by level. A lot more detail engineering. The buildings get looked at a lot more closely compared to your conventional system, but same philosophy.
Okay. Okay. So we have another question from Mr. Pratapji related to hydrocarbon industry. He's asking, is it beneficial to do precast resilient buildings using precast?
Again, I think yeah, beneficial in terms of the time premium. Like I said, that one building that we are doing for that HPCL refinery is they had the time advantage, right? Because even if the building scope is smaller, it's like we want that building up and running quickly. So they right from day one they said we want it precast because I want to wrap it up quick. So that is something where you will pay your premium and get it done. It's not straightforward to do a one small building in precast and then get out of it. But they wanted or they were willing to pay that premium. So it really boils down to what you really want, whether you are willing to pay that premium for that time factor.
So we have another question from Mr. Suresh Tripathi ji. So he's asking, how is your experience in usage of fiber in concrete, specifically precast?
Yeah, actually, we are not using fibers for now. Fiber, of course, they have their own benefits in terms of whatever crack control and all. But in our elements and all, in our experience, we felt that to manage that fiber mixing and all, ours are very small elements. If it's a large element, we are doing mega concrete pours, it's a different story. So in our experience, we were not that comfortable using fibers. The benefits versus that cost ratio was not working out well.
Okay. So Amit, I'll just wrap up just last one or two questions. So
Sure.
it is from Tripathi ji only. You touched upon the, digitalization also, uh, like how you people are monitoring. So we'd like to ask you, what is your insights or, vision for precast industry in terms of Industry 4.0?
Actually, this it's an open field, right? Right now, what I showed is still probably 10 to 15% of what we can do. Right, whatever I showed, it's still focused on the precast production process only. But then there is batching plan IoT is there. There is a crane IoT is there where I would love to look at it saying each crane handle that element for how long. And currently we don't have data. We just do the metric saying approximately 40 minutes to lagta hai. उस हिसाब से that's how we are planning. But with this industry 4.4 4.0 now, we will have to start looking at an overall holistic symbiosis between all facilities and then collect that data, saying exactly what I said is how long it took for the truck to reach. That way I can plan for the next job, saying usually 30 minutes of turnaround time is there. Batching plant connectivity, how long the mix was mixed and what was the workability at the time when it was poured. Your crane IoT is each element sensor giving me the data. So that will be then never ending. And this is still data collection, what I'm saying. Then you have to analyze your data, size your tenders, and go and quote your next projects. And that risk, what we usually build in terms of fluff, saying thoda idhar rakho, thoda udhar rakho, that will go away. That's where that whole digitalization is not just to use data for the sake of it. The long-term goals are is to collect the data and intelligently use that data so that you can be more efficient in terms of your pricing and costing.
So Amit, as you said about data, so I remember yesterday there was question about this. So would you like to, if you have any example about the life cycle cost of any building in India, precast versus conventional, if anything, because L&T must be having something or the other about that.
Yeah, I think we would love to have it. I have in my college days, I had looked at a little more on that life cycle costing, but to the best of my knowledge, we don't have something that will we have cycled through. Future projects, yes, we will be tracking and seeing the overall life cycle cost, but to the best of my knowledge, we don't have anything for now.
That is a great, yeah, as of now, we can say.
Right, I think that all these things usually, in my opinion, are driven by the industry. Currently, if I go and but it costs you 2 rupees more per square feet, it gets thrown out. Maybe over the time somebody has to see. Finally, I am a contractor, right? Out of our own pocket, nothing is going to happen. But maybe it comes from the government, maybe it comes from the client side saying you need to do these things, and let me see what how beneficial they would be, and then things will get rolling.
Okay. So thank you, Amit. We have a lot of questions also, but now it is time for our next session. So thank you from ICA Pune and Semcon 2021 for the excellent presentation and accepting our invitation and doing gracing this occasion. So thank you, Amit, for that. Now we will have a quick presentation from our one of the sponsor, Komansa. I'd request the Komansa, Mr. Ravi Narayan from Komansa to come on the stage and quickly introduce their products and services to us.
Let me introduce myself. I'm Ravi Narayan. I come from Escorts Limited, and with me is my colleague Sanjay Yadav. To give you a background, Escorts is a leading engineering company based out of Faridabad, and we have been here for almost 75 plus years. Our core strength has been over the years been on tractors, construction equipment like hydra cranes, mobile backhoe loaders, road compactors, and railway equipment division. And as we have been always trying to improve our product presence in the market with additional equipment through which we can support the business requirements. In 2009, we tied up with Comenza, and Comenza are a leading tower crane manufacturer. They are the inventors of the flat tops, and they are based out of Spain. They have two plants, one in Spain and one in China. And over the last 12 years, we have more than 100 units working with leading companies like Shapurji, L&T, Tata, Housing. I know recently we have bagged the prestigious award from My Homes for a 50-ton crane. As you could have seen in the previous presentation, how vertical transportation is important, how it cuts short your product costs, and also improves your, the doing away with form work, etc. So 2016 onwards, we have been focusing mainly on the precast segment, and we are happy to say that we have quite a good presence and we have very happy customers. Now I would request my colleague Sanjay Yadav to take you through the presentation, which will give you the product variants, what capacities we serve, and how are we different from the other makes. Thank you, Sanjay.
Thank you, Ravi sir. Good afternoon. My name is Sanjay Yadav. I'm from Escorts Limited India, representing Komansa Tower Crane in India. Since the online presentation on Komansa has already been delivered yesterday by Mr. Javier, who is the marketing head sitting at Komansa Spain head office. Since we being the sponsors of this event have been given the opportunity to showcase some of the unique and salient features of the Komansa tower cranes, which are being used preferably in precast constructions. So just quickly, I will take you through the various advantages of the Komansa, why the Komansa cranes are being used while lifting or while tackling the heavy panel weights. I will also take you through some of the projects which are being completed by employing Komansa tower cranes in India. As Mr. Weber in his presentation has shown that the two iconic precast projects, one of 120 meters height being developed, that is already developed by Arvindo Pharma in Hyderabad at High Tech City. Also, he has shown in his presentation that a 40-story building, which precast building, which is probably going to be the, you can say, tallest tower in South Asia, that is of 190 meters. And for that, I'm proud to say that the customer has chosen 4 50-ton Komansa tower cranes to execute this project. I would have been thankful to Mr. Vaibhav when he shown that Arvindo Pharma slide, wherein that 120 meters tall building already executed. That tower also was executed by Komansa tower cranes only. The capacity of the cranes was 18 ton. Here, in case of this 43-story building, which is being developed by my own construction, is going to be 50-ton class crane. Komansa has been the forerunner in creating a system of tower crane with modular concept, a strategy which is being adopted by rest of the industry because of it has got enormous advantages to the end customers. So Komansa is over 50 years old company, which is designing, manufacturing, supplying and supporting the customers across the globe. And this is the long legacy of 50 years experience in manufacturing a single product, that is only tower crane, has led Komansa to establish among the leading manufacturers and suppliers of tower crane across the globe. This is the global presence of Komansa. Komansa global headquarters is at Pamplona. That is, some of you might be knowing, a city of bullfights. Their factory, that is head office and factory at Pamplona. Another factory they have got at Hangzhou, China. From there on, they supply or cater to the needs of Asian countries. With over 20,000+ tower cranes across the globe already commissioned, serving to over 70+ countries. And since this being a very family-owned company, having a turnover of around 100 million euro. Some of you might be knowing that about Linden. Linden was, you can say, they were very strong and robust in terms of modality in designing the cranes in the late 1970s. Komansa took over Linden in 1983, added to its portfolio, and since they were so strong and popular that the Komansa could not dare to remove the name Linden from their original name, and still they are following or propagating the legacy of Komansa in the name of Linden Komansa even today itself. Since, as I told, the Komansa is the pioneer of flat top technology in tower crane. So because of having the flat top cranes have a lot of advantages over hammerhead cranes or the cranes with having the cat head, wherein the main jib is supported by slanting ties. So also the advantage of flat top is that while erecting or dismantling the cranes, part by part erection can take place, and with the smallest possible mobile crane, the erection of the cranes can be done as well as dismantling also can be done. Also, the challenge of tackling higher capacity panel weights is quite a lot in precast concepts. Hence, in precast concepts, only smaller capacity, smaller jiblets are being used because of tackling the heavy panel weights. So while doing so, being a flat top, if the few cranes are working in close vicinity to each other, they can overlap with each other with the shortest possible heights. Minimum resistance to fatigue. This is, as you all might be knowing, that the cranes with the where the jibs are supported by the ties, the portion of the jib which is just beyond the ties, it is most vulnerable and is that is having the most impact while lifting the heavy loads. But since in a flat top there is no tie, whatever the load lifted at any span of the crane, the impact of that lifting is being borne by entire jib length rather than the particular jib section which is beyond or within the tie bar. Also, the advantage of Komansa in design is that you will have the more advantage interchanging of mass sections as well as jib sections. If suppose you are having a 10-ton crane, tomorrow you want to reconfigure it to maybe 16-ton crane. So with the minimum possible change of, you can say, panels as well as jib sections, you can convert your existing 10-ton crane to higher version of 16-ton capacity crane. These are the common advantages of Komansa flat top tower cranes. Quicker and safe assembly. Storage is easy because all the mass sections, they can be further sub-dismantled in the form of panels. So when a lot more panels can be transported in a single flat top trailer. So you are saving a huge transportation cost. Also, the greatest advantage of the Komansa tower crane, that is the challenge comes when we work in the precast while tackling heavy panel weights. So while placing as well as while lifting the panels, the inching control is required to ensure safety while placing the high panels as well as while lifting the panel from the factory or from the loaded trailer. So these are some of the unique features I would like to apprise you about Komansa tower cranes. This is a double trolley. I think you all might be knowing that all the tower cranes, they have double trolley system, wherein both these trolleys can be split according to the working requirement. But here, the advantage in Komansa is that these splitting of these two trolleys can be done automatically by press of a push button. It takes 2 to 3 minutes for an operator to change over from two trolley to single trolley as well as and vice versa. Second, FE plus, what happens? Sometimes we have to work with the tower crane with the restraints of height. So what happens? The FE plus is a mechanism wherein a operator, when operates this switch, the speed of the crane comes down. So variable frequency drive takes care that the speed, since the VFD knows that the crane is working at smaller height, so there is no need to go for higher speed because there is a great probability of meeting accident. So the operator operates this switch, which ensures that from the fifth speed, the crane speed automatically comes down to third speed and it becomes safer to tackle the construction work. Then is power lift. This is a wonderful feature in Komansa tower crane. What happens? Suppose I have a tower crane having a lifting capacity of or transporting a load of 5 ton at 50 meters. Sometimes there comes a challenging situation at sites wherein the customer requires, say, this 5 ton to be carried to 51 meters or 52 meters. So the Komansa cranes, by virtue of this, their modularity, their design, it has the function or it has the option that it has an additional advantage of 10% more radius to be achieved with the same load. It means, as I mentioned, that 5 ton load, which are supposed to not go beyond 50 meters, you can go by 55 meters. Then is the level luffing. I think this is used in shipyards applications wherein the load has to be kept at constant, whereas jeep needs to be luffed up and down. Then cube cab, this is the red dot awarded cabin of Komansa. And quick set, as I told you, Komansa has the feature of inching control. While fitting the heavy panels, while giving a connections, very inching control is feasible. It is just in the hand of the operator just to push a button. The moment he pushes this button, the speed, the frequency drive boards down the speeds to dead zero, and it becomes very safer to place the panel and to grout it. These are the range of Komansa tower cranes. They manufacture from 4 to 90 ton capacity. 3000 series having the tower cranes from 32 to 90 ton. Also, they have luffers from 8 ton to 64 tons. Rest all mediocre range from 8 to 12, 4 to 5 tons. These are some of the projects, commercial and residentials, some of the cultural and sports facilities, some high-rise buildings, ports and shipyards, power plants, oil and gas, bridges, hydro plants, various ranges. Thank you.